And I think that's it for our graph. So this is it. We have got 3 survival functions built on this plot. We copy values starting from df, build probability density function, so we just copy and rename the data frame to df1, and this will be the det_f, which we have specified here and filled with the values of probability density, df1, 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 and df1. Here we need to change the title density functions, and so I need to find the mistake somewhere, because these values are not what they are supposed to be like. Let's go to our calculations and check. So the error should be somewhere here, and as in the previous version, as when we have built this, it wasn't so obvious, but here it is quite obvious that something is wrong. So actually we don't need the whole version of mu over here instead of the value, and we have this calculation. So let's rebuild everything, and voila, we have the values which now are larger than 002, and we have the maximums which have been found properly. The values for survival functions are the same, but the values of df are completely different, because there was the mistake in the calculation. So we just multiply it redundantly on the same, and instead of det_s we multiply it on det_s squared. So after we have found the values of probability functions, so now we are ready to comment, and the results of the maximum functions are about t equals 60, this is about that, and here is t about 30. So indicate that def is most likely to occur around age 80. The decreasing form of the density for age 80 also indicates that def is more likely to occur at age 80 than at any other age for life now aged 80. A further point to note about these density functions is that although each density function is defined on 0 to infinity, the spread of values of fxt is much greater for x equals 20, this is the spread, the variance, then for x equals 50, which as we see results in a greater variance of future lifetime for x equals 20 than for x equals 50. Let's look again on the survival function figure. So there are some general points about lifetime distributions. First, we see that an effective limit in age, even though in principle there is no age to which the survival probability is exactly 0. We see that as xt more than 0 for all combinations of xt, survival beyond age 120 is very unlikely. So we have these values which are approximately 0 starting from age 80 plus.